Hello everyone and welcome to the physics basket, and this is the topic 4 where we are going to discuss on the different problems on distance and displacement. So let's get started. So let us start with the problem. So a car travels 4 kilometers towards east and turns to north and travels another 3 kilometers. And the ask is to find distance traveled and displacement. Let us draw a diagram. The car is traveling 4 kilometers to east, turns to north, and travels another 3 kilometers. This is how it has traveled. Now, when we need to find the distance, we know, as per the simple definition of distance, it is nothing but the total length of the path traveled. So, which is nothing but, if these are the 3 points A, B, C, then the distance is AB plus BC, which is nothing but the total length of the path traversed. So it is 7 kilometers, as simple as that. And then we need to find the displacement. As we know, displacement is the shortest path between the starting point and the end point. And in this case, AC is the displacement, as we can see. Since it is a right angle triangle, we can find AC using Pythagoras theorem, wherein AC equal to AB square plus BC square root. Taken together, we get AC equal to 4 square plus 3 square whole square root, which is nothing but 5 kilometers. And the direction is towards northeast. So let us attempt the second problem, wherein a bus moves from the starting point 3 kilometers to east, then 2 kilometers to north, followed by 2 kilometers to west, and then 2 kilometers north again, and then finally 2 kilometers to east to reach its destination. And the ask is to find the total distance covered and the displacement by the bus. So in these kind of cases, it is always better to draw a diagram to visualize the whole thing. So the bus, as we know, it has traveled to east for 3 kilometers, then towards north 2 kilometers, then to west for 2 kilometers, then towards north again to 2 kilometers, and finally 2 kilometers towards east to reach the final destination. And this is how the path of the trajectory. As we know, the distance is the length of the path traversed. So in this case, it will be as simple as adding all this path together, which is nothing but 3 plus 2 plus 2 plus 2 equal to 11 kilometers. Now we need to find the displacement. As per the definition of displacement, displacement is the shortest path between the starting and the end point. So in this case, this will be the displacement, the yellow one. So if we draw the lines across the whole trajectory, we will draw a right angle triangle where AC is the displacement, whereas BC is the perpendicular and AB is the base. We know the value of AB already. For BC, we know this part is nothing but 2 kilometers again. So the BC taken together will be 2 plus 2, nothing but 4. So again, using the Pythagoras theorem, we know AC is equal to square root of AB square plus BC square. And again, we get square root of 3 square plus 4 square, nothing but 5 kilometers towards the northeast direction. Let us attempt another problem. This is an object is moving along a circle of radius a. Find the distance and the displacement by the object when it covers 3/4 of the revolution of the circle. It is very good to draw a diagram to visualize what things undergo here. So here we see a circle. The radius is A, as we know, and this is the object A, capital A, and then it's traveling across the circumference of the circle, and it has traveled and moved 3/4 of the circle, and it reaches the point B, as we know. Now, what is the distance traveled? So distance is basically the total length of the path traversed. Basically, this highlighted portion is the total distance. Now we know the circumference of the circle. So circumference of a circle in this case will be 2 pi a. And since it has traveled 3/4 of the circle, which means that it is as simple as 3/4 of 2 pi a, nothing but 3 by 2 pi a. So that is the distance the object has traveled. Now we need to find the displacement. Coming back to the definition of displacement, if you pause and remember what we should do, it will be nothing but this portion, right, between A and B. So it was here A and then it has reached B. So again, let's draw. This is AA, which is nothing but the radius, and this is the displacement. So again, we are seeing a right angle triangle here with the base equal to A, the perpendicular also equal to A, and we need to find AB, which will give us the displacement. So which is as simple as using the Pythagoras theorem again, square root of A square plus A square, and that is equal to root 2A. So let's attempt the next question. And the question is, a ball as shown below moves along its axis by 180 degree. We need to find the distance and displacement of a particle A as shown in the figure. So this particle A is down and it moves by 180 degrees. So let's move this ball forward. All right, so we are moving this ball forward. We can see it has moved by 180 degree, which means that the A has become inverted. It comes to the top. And this was the previous position here. This is A here. And then when we try to visualize this, the total distance the particle A has traveled is basically from this point till this point, because of which, since the ball also moved, the A is actually located here, the object is located here, which clearly means that the object has moved through half circumference of the circle, which is also the distance that the ball has traveled in the forward direction, right? Which means that this distance and also this distance is equal to half of the circumference of the circle. So circumference of the circle is 2 pi r, and since we need to know the distance, which is nothing but the total length of the path traversed, nothing but this particular highlighted portion, and we can simply get it 2 pi r into half, nothing but pi r, which is the distance traveled by the object. Now since the ball has also moved in the forward direction, which means that it has also moved by the same distance because of this rotation. So ball has rotated by half circumference, and this particular bottom of the ball also moved by the same distance. That is where we can find the displacement, and we know displacement is the shortest part between the initial point and the final destination. In this case, it is the straight line between A and the inverted A. Now going forward, this is the displacement, and if we draw a right angle triangle, this part is 2r, nothing but the diameter of the sphere, and this part is pi r, which is equal to the half circumference of the circle by which the ball has actually moved, because of which the forward movement also happens. So with this, it's very clear that we have the base, we have the perpendicular. So we will be able to find out the hypotenuse, which is equal to square root of pi r square and whole square of square root of pi r whole square plus 2r whole square, and which gives us final displacement value as whole square of pi square plus 4 into r. That's our final answer. So thank you guys. That brings us to end of this topic. And the next upcoming topic is the topic 5, where we are going to discuss on speed and velocity. Till then, thank you and bye bye. Subscribe for subsequent updates.